Imagine standing in an empty field. Your task is to build a massive, highly complex industrial facility right here, starting from absolutely nothing. In engineering, we call this a greenfield project. It means designing and constructing a heavy manufacturing site entirely from scratch. Success here means anticipating every possible challenge and solving it on paper long before a single brick is laid or concrete is poured. To survive the intense demands of production, a megafactory requires a precise internal architecture. It operates exactly like a giant living organism. Before this mechanical body can get its muscles, the heavy manufacturing machinery, we have to equip it with essential lifelines. This maps out the 7 distinct utility systems required to keep an industrial plant alive, including water supplies, compressed air, and industrial fuels. At the top center, you'll find the absolute most critical system, electrical power. It drives every mechanical gear and digital sensor. Electricity acts as the beating heart of the entire operation. If the electrical infrastructure is poorly designed or fails, the entire organism dies. Raw power arrives from the external grid at dangerous voltages, sometimes over 200,000 volts. You need serious infrastructure to catch that energy from long-distance transmission lines. Notice the immense scale required in an outdoor receiving substation like this. You can't feed that raw extreme voltage directly into a factory. It has to be stepped down, like a pressure valve that reduces a high-pressure fire hose to a garden hose. That step-down process happens inside a transformer. This piece of heavy equipment lowers that extreme voltage down to a safe, usable level for the facility. Together, these receiving substations and transformers serve as the main arteries, safely conditioning the massive rush of energy right before it enters the localized network. Once the voltage is safe, the system directs it to thousands of different machines at the exact same time. We do this using switchgears and motor control centers. They are the brain of the electrical system. Inside an industrial electrical room, you'll see long rows of control panels. The scale required to manage a factory's power flow is massive. This grid breaks down the incredibly varied loads this brain must manage. It balances massive energy draws like heavy motors and heating kilns with highly sensitive loads like computer networks and lighting. Modern smart panels use digital communication to orchestrate this entire distribution, acting as a true central nervous system for the facility. But what happens to this sensitive electrical nervous system if nature attacks with a sudden 30,000-degree lightning strike? This diagram illustrates the factory's lightning protection system, engineered to intercept and neutralize atmospheric strikes. The air rod captures massive voltage, funneling it down the down conductor. Energy is safely dispersed into the soil via the earthing system, while surge protectors shield internal digital networks. Without this meticulously engineered shield, a single environmental event could instantly fry the factory's brain and halt operations entirely. Once the physical components are mapped out, engineers measure how efficiently the organism actually uses its energy over time. This dashboard highlights a critical calculation called the load factor. It measures how uniformly and smoothly power is consumed across the entire site. There are real commercial consequences here. Utility companies severely penalize factories that consume power erratically in massive, unpredictable spikes. By designing the facility to maintain a high load factor from day one, engineers secure highly favorable electricity rates. This drastically lowers operational expenses over the lifetime of the factory. Precise electrical engineering directly generates long-term financial savings. Designing this heart, brain, and immune system happens entirely on paper before construction ever starts. This chart tracks the timeline of a greenfield project. You can see how initial preparation phases lead to the massive deployment of funds for construction. Detailed engineering during those first 4 phases reduces financial risk before upfront construction costs skyrocket at the acceleration point. Designing the factory's electrical nervous system is how you secure its future before a single dollar is ever spent on building it.